Question 4 is our Simpsons rule question, and we're going from 0.5 all the way up to 2, and it says we've got to do it in 6 strips. So let's split this into 6 strips and work out what the values are. Looks to me like it's going up by a quarter each time. Does that work? 1.75? 2? Yes, it does. So they're the X numbers, and we've got to work out what the Y numbers are. And just throwing this value into that equation there on my I'm getting 4/9. I mean, I think leaving it as a fraction's probably a good idea, because then you're going to get the accuracy perfect. We've got half there, that's okay. 80 over 189 there, much better than the 0.4233 and so on. 12 over 35, my calculator's telling me 112 over 407, and that one there's 2/9 again. So the Simpsons rule says that it's 1/3 times by h, or the distance between them, that's a quarter, times by, now this big total here, remember, it's just one of those and one of the ones at the end there. You've got 4 of all of these ones and 2 of the other ones. And when you work all of that out, you stick that in there, you times it by a 12th, and the final answer is 0.605. And you need that accuracy. It needs to be 605, not 606. Part B, you're asked to do this integral from 0 to 1. And a lot of people are going to spot the answer immediately, because the bottom bit differentiates to a third of the top bit. So a lot of people are going to write this down straight away, 1/3 the ln of the bottom bit. And that's going from 0 to 1. And then throwing in those values, throwing in 1, we're getting 1/3 ln 2, minus putting in 0, 1/3 ln of 1. Well, the ln of 1 is just 0. So we've got a final answer of 1/3 ln 2. Now, if you don't spot that straight away, you're going to have to use a substitution. And your method would be to substitute the bit on the bottom, u equals 1 plus x cubed. When you differentiate that, you get 1/3, sorry you don't, you get 3x squared. And this is what I was thinking, that when you rearrange that, you get dx, you get du over 3x squared. Let's put this and this into the integral now. So we're looking at the integral of x squared over u du over 3x squared. The x squared cancels, leaving us 1 over u du. Of course, 1 over u du integrates to the ln of u, and what was u? It was 1 plus x cubed. So we're now back up there, but much longer. We've still got to do this between 0 and 1 like we did before.